Okay, this is Mr. B. I'm going to go over how to do some of this polynomial division because I'm seeing a lot of confused faces. So we're going to use the anti-box method that we've been using the entire time. First off, as you see, we've got our big polynomial here, and it's being divided by our smaller binomial right here. And first off, let's get that box drawn out. Okay, so first off, let me apologize. I'm still learning how to use these tools, but I know it looks a little janky, but we can still do it. All right, first off, step number one, we want to get our divider where it should be going, and that is right here. I'm going to put x, and I'm going to put, it's a positive 3, so there we go. Next up, because we're doing this box method somewhat backwards, I'm going to put this guy right here over here where usually our box would yield the answers. I'm going to put what we're dividing by, this polynomial right here. I'm going to put those monomials right here. So we got 10x, and we got 12. Next up, the next step on your thing is to fill the corners, and I'm talking about this corner here and this one right here. Now usually I'm going to say this square plus this square equals this number. So whatever x squared term I put here plus whatever x squared term I put in here is going to add up to this one. Likewise, whatever I put in here, whatever x term I put in here plus whatever x term I put in here is going to add up to 10x. This one, as well as this one, don't have any like terms. And because of that, I can just instantly say that I know x cubed is going to go on there. Hold on. Let's get a better cubed. I know that x cubed can go there, and I know that 12 can go in there. Let's get a better 2. Yeah. So this is our starting point. And now I'm going to take my 3, and I'm going to say 3 times what number would equal 12? 3 times what number equals 12? And the answer is 4, right? So now that I have this box filled out, just like the normal box method, this row would normally be there, and this row is always there. And we're just filling in each and every little box in there. But now I can sort of work backwards. I know that this box is going to be x times 4, which would be, drum roll please, 4x. Okay, let's take it over to this side. X times what equals x cubed? X times what equals x cubed? Well, the answer is going to be x squared. And now once again, I can take my top row times my side column. I can say 3 times x squared equals, that's right, 3x squared. Boom. We've got 2/3 of this thing already filled out. Now, how do we get this center row? This is the biggest step in my opinion. Okay. As I told you before, this box plus this box is going to equal this box. So can anybody think of a number? 3 plus something equals 5? And yeah, it's got to be 2. Whoa, bad 2. It's got to be 2. And because these have to be like terms, I know that this 2 is going to be x squared. Similarly, I know that this 4x plus whatever's here is going to be 10x. So 4 plus something equals 10x. And of course the answer is 6. And then again, these have to be like terms, so I know it's going to be x. So now my whole table's filled out except this weird middle term. And the way we test this out is we say x times what equals 2x squared? X times what equals 2x squared? And the answer is going to be 2x. And now the truest test. Does 3 times 2x equal 6x? And it does. So we did it. We turned this thing around. That's great.